Hello students, in this video we will see few numericals to find the power of an engine or pump. So if you see the previous question papers, regularly he has asked a problem on this. So here I have taken a few problems on finding the power of a pump where he will be giving efficiency etc. So if I take first one, this is a simple basic. Water is falling on blades of turbine at a rate of 6000 kg per minute he has given. Means mass of water he has given 6000 kg. Time per minute he says means 1 minute, that is 60 seconds. You should convert it to SI. And the height of fall is 100 meters. So H is equal to 100. Find power of a turbine. So by definition, power is work by time, or work done is stored as energy. You can take this as energy by time. Now here, if you see has given height means energy, I will take it as potential energy. Potential energy formula is mgh time t. Now substitute all the values. He has given all values over here. Mass is how much? 6000. G is 9.8. Height is 100 meters divided by time. Time is 60 seconds. Simplify, you will have the answer. So 600 into 9.8 into 100 divided by 6. So you will have 98,000. 98,000 units is watt, or even you can write this as 98 kilowatt. 98 kilowatt. Clear? Now we will go for the next one. So mainly you will find questions in this form. First one was very simple. So now if I take second one, a water tank measuring 4 by 4 by 2 means he has given volume. So he has given volume 4 into 4 into 2 means volume is 4 into 4 into 2. So multiply 4 for 16, 16 to 32 meter cube volume. Is at an average height of 10 meters. So height he has given 10 meters. Above the ground level. What must be the power of engine working at 80% efficiency? So efficiency has given 80% means 0.8. If it fills the tank in 100 minutes, time he has given 100 minutes, convert it into seconds means 100 into 60. So 100 into 60. So 1 minute is equal to 60 seconds. So if you multiply, you will have 6000 seconds. 6000 seconds. Now, so rough if I take a diagram, so for understanding, so you can say this is ground level. Ground. There is an water tank at a certain height. So here there is a water tank, you may say. Tank at a certain height, so water tank. There is a pump or motor, you may say, pump I will take, which fills water in this tank. So water is filled by this tank. So now what all he has given? So volume of this tank he has given 32. Height of this tank from ground he has given, that is 10 meters. What must be the power of engine working at 80% efficiency? So efficiency is 80%. So whatever it gives power, so to lift, this I will take it as power output For engine, what we are giving power or current, you can say that I will take it as input. So first, in a last problem I had taken power is equal to energy by time. Energy is mgh by t. Now here he has not given mass, indirectly he has given volume and density of water. So we know that density is equal to mass by volume. Density rho is equal to mass by volume. So m I can write it as rho into v. Rho into v. So if I substitute, I will have formula in place of mass rho v g h by t. Now substitute all the values and simplify. You will get power. So this power which we are calculating is power output, that is required to raise the water to height 10 meters. So here I will write it as a power out. So whatever we are calculating, that is power required to lift the water. So density of water is 1000. Volume he has given 32. G I will take 9.8. Height 10 meters, whole divided by time taken. Time taken to lift is 6000. So in one step you can calculate. Again 3 zeros gets cancelled. So I will use calculator. 32 into 9.8 into 10 divided by 6 divided by 6. So you are having 522.67. So 522.67 watt. So this is power output. But what power of engine is required, he has asked. So what must be the power of engine, he has asked. Engine is not 100% efficient. So if you take engine or pump of this power, that is 522, it will not lift water up to the tank. ಯಾಕಂದ್ರೆ ಅದರ efficiency 100 ಗಿಂತ ಕಮ್ಮಿ ಇದೆ. By definition of efficiency, so efficiency is defined as output by input. So power out by power in. So using this you calculate input power, that should be the power of engine required. So power input is power out by power power out divided by efficiency, divided by efficiency. So divide it by 0.8, you will have the answer, power out by efficiency. So if I substitute 522.67, efficiency has given it as 80%, means 0.8. So if you divided by 0.8, you are getting 653.33. 653.33 watt. This should be power of engine required. So this is the answer. Clear? Generally has asked problems of this type. Similar to this, means efficiency will give, you are required to find power. If I take another problem, a tank of volume 2000 meter cube. So V he has given. So volume he has given. Volume. It is filled with water in half an hour. So half an hour here time he has given. From a well 50 meters below the tank level, means H he has given, or you can say depth. Calculate power of engine. Here power of engine he has asked. If 40% of power is wasted, this you should read correctly, wasted. 40% is not efficiency. 40% is wasted, means efficiency is 60%. What should be the actual power? So here you are required to find input power. Here you are required to find output power. Clear? Now if I take rough for understanding, so you may say there is a to pump the water from a well. So there is a well, it is having water. So well, so here there is a pump or motor which is used to lift the water from the well. So it is used to lift the water. So again note on all the values. V is equal to 2000 meter cube. Time he has given half an hour. Half an hour means 30 minutes. Convert it into seconds. So 30 into 60. You will have 1800 seconds. 1800 seconds from a depth. So H I will write instead of D 50 meters. You are required to find power used to pump the water, means you are required to find power output and even actual power means input power. Efficiency he has given 40% is wasted, means efficiency is 60%. You can solve easily. Note down the formula and substitute. So first, if I take actual power, power used to pump the water, power to pump water, power to pump water. So P is equal to, directly I will write mgh. M is written as rho into V, gh by T. Now substitute the values. Density of water is 1000, volume is 2000, G 9.8, height is 50 meters, time taken is 1800 seconds. Now simplify. Two zeros gets cancelled. So 20 will go. So what remains in the numerator? 9.8. Just I will remove the zeros. 2 into 9.8 into 5 into 10 raised to 1, 3, 4, 1, 5. So 10 raised to 5 divided by 18. Now simplify. You will have power. So 5 into 2, 10, 98 by 18. You will have 5.44. So 5.44 into 10 raised to 5 watt. So this is power required to pump the water. But efficiency is less than 100.6 efficiency is there, means actual power you are required to calculate. So efficiency, actual power, by using the definition of efficiency. Efficiency is equal to power output by power input. So power input is actual power. So power input, or you can say power actual, is given by output power by efficiency. Substitute. Output we have got it as 5.44 into 10 raised to 5, and efficiency is how much? 0.6. So divide, you will have the answer. So if you divide, you will have the answer divided by 0.6. So answer is 9.07. 9.07 into 10 raised to 5 watt is the actual power. Clear students? Hope it's helpful to you. Again I request you to share with all your friends.